Hi pre-calc. Okay, today we're going to do 2-3. This is polynomial and synthetic division. We usually call it long division and not polynomial division, just to clarify, just so you're sort of more clear on what I'm trying to ask you. Just in terms of lingo, and again, I don't test on lingo, when you're doing long division, this guy under here is called the dividend. This is the divisor. The quotient is what you find, and the leftover is the remainder. Okay, just the lingo. I just want to go over a really important point here, because this little thing, if you don't get this right, it just will totally confuse the heck out of you. So just try to remember that when we do division, let's see here, 8, 9, 8, okay. I'm gonna need more coffee this morning. Okay, so we have to remember that when we do division, that it's implied subtraction. So you actually introduce that subtraction sign there. So you'll notice I'll write this with my red pen to help remind you that you have to opposite the sign. All right, let's start with long division. So this is the problem I'm going to give you. So this is the dividend, and this is the divisor. We're going to find the quotient and the remainder. Now it's missing the cube degree, so either you have to leave a gap, or you can say, some people will say, I have no x cubes. It's up to you. You have to do something. You can't ignore that you have no x cubes. So again, either you can just leave a gap here, or you can say that you have 0 of this type, just so you have something to look at. Because when you do long division, everything lines up in a column, and so you have to have a column for each degree. Otherwise things crisscross and it gets really confusing. All right, so there's 2 ways to think about this. The first way is what times this makes this. What times the first thing makes the first thing. The other way to do it is this divided by this is that. This divided by this is that. So whichever way your brain does it. My brain does multiplication, because this times this is this. All right, so, but just remember, when you're doing it, you actually have to do it to both. So x cubed times x is x to the 4th, and x cubed times 3 is 3x cubed. And then we're going to go back now to what I was just saying earlier about this minus. You introduce this. So some people write it out front like this. Some people write it out front and like distribute it in. My brain likes to just put it in. So it just, you know, you do it your way, whatever you like best. My brain actually wants to see the sign changed on each of them. So everybody changes sign. This goes away. 0 minus 3 is a minus 3 of this type. Right, now I bring the next term down. And now I do it the technique again. What times the first term makes the first term? What times the first term makes the first term? Or if you like it the other way, this divided by this is that. This divided by this is that. Okay, my brain likes the multiplication, so it's going to be negative 3x squared. Okay, so now I have to multiply this to both. Okay, this times this. They should initially match in sign, because you're going to opposite everything. Okay, so again, some of you put brackets and a big negative out front, and you distribute the negative as you do it. I just put the negative, I distribute it right away. So a negative negative makes a positive, a negative negative makes a positive. All right, this goes. Bring down the next guy. Right, so the pattern's just going to repeat now. So whichever way you're doing it, you know how to do it now. Okay, negative x. Opposite the signs. Next. Okay, that'd be a 1. Okay, so that's the procedure. You should have seen long division before. This should not be the first time you're seeing this. Okay, so now what I'm going to do is I'm going to take the same question. I'm going to take the same question that we just did. Okay, we just did this one, and I'm going to show you synthetic. Now, I'm only going to show it to you once here, and it's just because in the next section that we're doing, I'm going to do this a lot, so I just don't want to overkill it. You'll get it. You'll pick it up if you don't get it right away, but you're probably just going to get it right away. It's not a crazy difficult concept. Let me just clarify something here, though. Synthetic division is really, really fast, and it's a really cool way to get the quotient, but synthetic division only works if your divisor is linear. So what happens is when people see this, they're like, oh my God, I'm never doing long division again. Long division takes so much time, blah, blah, blah. But that's not an accurate statement, because long division, your divisor can be linear, it can be quadratic, it can be cubic. Long division can handle any kind of long division. Any type of division. Like your divisor can be any degree. Where synthetic division, your divisor can only be linear. If this is not linear, you can't do this technique. So what I tell the students is long division is sort of similar to the quadratic formula, where the quadratic formula always works, and synthetic division is like factoring. If it works, it's fast, but it only works in certain scenarios. So it's sort of like that. Okay, I was trying to get the nice sunlight. Let me see if I can move the table a little bit here. The nice sunlight is lovely. Okay, we got it again, I think, until it shifts on me again. Okay, so this is how you do synthetic division. You flip the roof, so it's sort of like upside down to the long division sign. You just put in the coefficients. Don't put in any variables. So the coefficient on the x to the 4 is a 1. You have to, just like long division, you have to hold all the places. So since there's no x cubed, I have to put a 0 in for x cubed. Okay, x squared has a negative 10. I'm just putting in the coefficients. This has a negative 2. And this has a 4. Okay, so that's the setup for like in the house, so to speak. Now this is going to look a little confusing, but this is how you do the divisor part. You set the divisor equal to 0, and then you solve it. It's going to give you a negative 3. So it's like if it was an x-intercept, what would it be? All right, so I'm going to put the negative 3 here. All right, it goes really fast, so pay attention, okay? You always pull the first number down. You just pull the first number down, whatever it is. Then you multiply this times this. I'm multiplying. You put it here. Okay? I multiplied this times this. I put it here. Now I'm going to add. I'm going to add this. The pattern repeats, okay? It's going to repeat after this. I just did a whole cycle. All right, here we go again. I'm going to multiply this times this. So negative 3 times negative 3 is positive 9. I'm going to put it here. I'm now going to add this. This is negative 1. So this part is multiply, this part is add. All right, now we do it again. Negative 3 times negative 1, that multiplies to 3. This adds to 1. This multiplies to negative 3. This adds to 1. Now the last one you put in a box because this is the remainder. This is the remainder. Now what is here is the quotient. So you can sort of go backwards. This is the constant. This is the coefficient of the linear term. This is the coefficient of the quadratic term. This is the coefficient of the cube term. If there had been more, you would just go up the ladder, right? So this is the coefficient of the constant. This is the coefficient of linear term, quadratic term, cube term, like this. It's giving you the coefficients. So it's x cubed minus 3x squared minus x plus 1. This is the quotient. And the remainder is this 1 over this. So if you notice, that's the same thing. That's the same thing. Wow, the sun is so good here. It almost looks like I'm in the pitch dark. You can tell that this and this is the same. We got the same answer and we got the same remainder, right? The remainder was 1 and this was 1. Okay, so that's how you do synthetic. Again, you're going to see that a lot more times if that wasn't enough for you. Just some quick little notes. I love the sun. It's making it look like I got a spotlight. Okay, just quick little notes. The remainder theorem. So what we want to do is, for the next section, we're going to want the remainder to be 0. So this theorem tells you that if you plug in the value, you can see what the remainder is. So like, if you plug in the x value, the y will be the remainder. Some other little things here, the factor theorem. So if this is equal to 0, then if your remainder is equal to 0, then this part over here is your factor. I'll show you that when we get to the next section. Again, if you're STEM, the book has like a lot of little stuff that I wish I could have a lot of time to do, but you can sort of fiddle through it and check it out. Now I'm just going to give you a tiny bit of stuff here. Hopefully we can see it in this sunlight. I'm going to give you number 15. I want you to do that one by long division. I'm going to give you number, not everything circled here, so just be careful. I'm going to give you number 27, that's synthetic. And I'm going to give you number 33, that's synthetic. Now number 33, notice that, oh no, it's not it is missing a linear term. So notice 33, there's no linear term in between the quadratic and the constant. So don't forget when you put it in the box to put a 0 there for the linear term. Okay, gang, that's it for 2-3. I'm going to pick up on 2-5. We're not doing 2-4. That's complex numbers. You guys know that. All right, catch you. Bye-bye.